Yep.
Presentation there. Perfect. Great. Okay. Well, yeah, thank you everyone for joining. As Pam said, my name is Meg, and I am presenting today with my coworker Megan about how we develop wind projects, and we will use the Wocawson Energy Project as an example throughout our presentation, which is the project that our company, Natural Forces, owns in partnership with Tobique First Nation. So we've done all of our work for this project with Tobique. Yeah. So yeah, just to give you a quick introduction to us, my name is Meg, and in school I did, so after high school I did physics, math, and environmental science, and then I decided to go back to school again and do some community planning work. And then we've got Megan, who focused her studies on environmental science. And both of us then got our positions with Natural Forces, where we work closely together on the development team. So we get our projects started, then we pass them off to our construction team to build the projects, and then they are passed on to our operations team to then sort of operate our projects longer term. So Natural Forces is the company we work for. We are a renewable energy power producer based in Halifax. So Megan and I are both in Nova Scotia, working, of course, from home right now. So we develop, construct, and operate, and then own wind, solar, as well as small hydro projects. So today we're going to focus on wind, but we do a variety of different types of projects. So Megan and I do our development work all across Canada, but we have similar teams that do this type of work in Ireland as well as New York State. And in developing these projects, Natural Forces partners with mostly First Nations, but also we have partnered with corporations, universities, and different types of community groups in the past as well. Yeah, so that's an intro, and now I'll just jump right into the project. So we're going to talk about the Wocawson Energy Project. So just some quick facts about the project. It is a 5-turbine wind turbine project. Each turbine is approximately 200 meters tall. So if you really think about that, that's quite large. And you can see the photo here is that project. It was commissioned late last year. And so the turbines are spinning in that, well, you can't see them spinning, but they are spinning in that photo. And so in total, the project produces about 20 megawatts of energy. And to put that in perspective, that is enough to power about 5,000 homes. So, and that actually is much more than Tobique First Nation overall. So it's an exciting type of project where they have successfully offset their energy demands, which is pretty amazing. So Wocawson actually is a Wolastoqey word that means great wind bird, and so it sort of represents the winds. And the name came out of our partnership with Tobique First Nation. So they helped us find that name, and that was an exciting sort of early step in our project. So yeah, as I mentioned, Natural Forces has done all of the work for this project in partnership with Tobique First Nation. So this means that we've made all of our decisions together, and we've both invested in the project, and we will both maintain ownership of the project long term. So the goal of this type of partnership is really, or one of the main goals of this type of partnership is to learn from each other. So we as Natural Forces have learned so much about the community and the lands from this partnership. We have really benefited greatly and gained so much. And then sort of on the flip side, as Natural Forces, we bring expertise on how to develop wind projects with the intention of, passing this knowledge on so that the communities we partner with, such as Tobique First Nation, can pursue their own projects in the future. And it's a really exciting way to go about a project. So when I refer to we throughout the presentation, the same with Megan, we're referring to the Wocawson Energy Project, which is Natural Forces and Tobique First Nation together. And so these are a couple of pictures of when the community went out to the site in the summer, fall. I'm not sure when exactly it was, but you can see there's a turbine standing behind them. So it was definitely last year. I think it was in the fall. So how long does it take? So for this project, the development phase, which is everything up to construction, took 3 years. And Megan and I will talk about this in detail in the coming slides, but just for reference, construction then took 2 years, and then the operational period will be for 30 plus years. So it'll be at least 30 years and hopefully more. So the development phase is what we're going to take you through today, and we'll reference the Wocawson Energy Project throughout. Though some of this information is certainly more general for wind projects and how development works. So this phase has many steps, which include finding a good site in the first place. Then we collect wind data. We need to find a good interconnection to the existing grid. So in this case, it would be the New Brunswick Power grid. Permitting the project, which as well as consulting with rights holders and stakeholders. And so that's all sort of those particular topics or tasks kind of start at the very beginning and continue throughout our whole development, and the consultation part will continue past the development phase as well. And then we need to finalize the layout and choose the right turbine technology for the project site. So we're going to go into each of these. So we'll start with site finding. So the first thing we need is to find a good site for our wind project. And what we do is we start with the data we already have on hand to be able to find such a site. So a lot of this work is actually just desktop work. It's work we do on our computers. And then we'll drive around and sort of make sure that, we haven't missed anything glaring as we do this work. So wind speed is a really big part of course, finding a good wind site. We use in New Brunswick, the province-wide New Brunswick Wind Atlas that shows us the windiest areas. Then we look at other data, such as the location of the existing grid, location of residences, roads, watercourses, and wetlands, as well as different land ownership and land availability. So I'm going to go through a series of maps to sort of show you how this process works and how, as we add these different constraints to a map, to the map we're looking at, that we sort of really limits where you can develop a wind project. So to start off, I'll show you here. So the town of Sussex is shown on the left, the bottom of this map, and the location of the Wocawson Energy Project is on the right. And so I'm going to keep adding data to this map, but this is sort of our reference map here. So in this map, I've added watercourses, wetlands, and water bodies that have been already mapped by the province. So these are areas we, sort of want to avoid if we can. So then I add here the existing roads, which are shown in black. And so these are areas, we want to be close to roads if possible, because that means that access to our site could be easier. But of course, we don't want to be too close to a road for installing a wind turbine. So that's sort of a balancing act. And then the orange lines are the existing New Brunswick Power electrical grid. So we want to be close to these so we can connect into the grid so that the electricity produced by the project moves to the houses and buildings in New Brunswick. Okay, so then the next one here is I'll add a 1 kilometer setback from houses. So the red area here shows the setback from all the houses, all the residences in this area. So all that red area is areas that we cannot develop in. So it's sort of the standard setback requirement for wind turbines is at least 1 kilometer from a house. And so you can see that this is one of our biggest constraints in site finding. It sort of naturally limits where we can look for wind development. And then you can see there's a couple purple areas I can show you here. These are protected areas that, of course, we will avoid any protected lands when we're in development. Okay, and then finally, I'll add white lines. The white lines here are all the boundaries of lands that are owned by different people, companies, government, what have you. The goal, there are kind of 2 goals with this type of data in site finding. One is that fewer land parcels makes development a little bit easier, but that's not totally a limiting factor. More importantly, we need land parcels that are not either already being used by other wind development or being used by land uses that are not compatible with a wind project. So a good example of that would be like an airport. You probably don't want to put a wind turbine right next to an airport. That wouldn't be terribly safe. So that's just one example. So in this case, the Wocawson Energy Project is on quite a large land parcel, you can see, and it is land owned by the province of New Brunswick. So we've worked with them a little bit on this. And then from this map, you can sort of see that there are a few areas that, could possibly work for a wind project. So of course, this area here where the project is, and then there's sort of a corridor up here, and then a couple down here that are close to the grid, but, not taken out by the residents, 1 kilometer setback from residences. So then, and sorry for the quality of this data, I'm pretty zoomed in on this map, but so if you keep your eyes sort of on those areas, you'll see that when we look at wind resource, the darker colors show higher wind speeds, that the Wocawson Energy Project is in a pretty good windy area. So for the project, the turbines are actually aligned in this orange area where the wind is stronger. And yeah, so this sort of collection of data shows that that's how we sort of narrow down in on the sites that are best for wind development. And in reality, I've shown just a small section just to show the Wocawson Energy Project, but really when we do this type of exercise, we look at the entire province and then narrow down sites, and this was one of the ones that came out of that. So it does take a lot of time. Yes, so then as you can tell by the quality of this data map, it's not the most fine data we can get. So it's important for us to then also collect wind data on our sites that we select so that we can have better quality data for our actual site. So there are different types of devices we use to collect wind data. So on the right-hand side, this photo here shows a meteorological mast or a met mast. These towers are 60 or 80 meters tall and have devices kind of all the way up that measure the wind speed and direction. On the left-hand side is a photo of a SODAR. That's a sonic detection and ranging device. These devices send sound signals into the air. They bounce back and are shifted in such a way that allows the device to measure the wind data or the wind speed at different heights. And these devices can actually measure wind speed up to about 200 meters into the air. So they're super valuable for us. And then the middle photo, it actually just shows the solar panels necessary to power the device that is powered, but it's called a LiDAR. The LiDAR itself, it's light detection and ranging device. It's basically just a little box, and it does the same thing as a SODAR, but uses light instead of sound. And so all three devices are powered by solar panels, generally speaking. So we collect all this data for at least a year, and then we can use it to predict the wind speed across our whole site to then place the turbines in the windiest spots. So then, of course, we do have to connect our project into the existing grid, so the electricity can be circulated to homes and businesses and schools and any kind of building. So there's two kind of grids you see in the province. So the first is a distribution grid, and so that's the type of grid that you would connect smaller scale projects to. These are the lines that go, they usually follow roads and they'll go right to your house. And so that's a picture of that is the bottom photo. So these are sometimes just straight poles, and then other times they're the T-poles like you can see in that picture. And then there's the transmission grid, which you can connect larger scale projects to, like Wocawson. And these are lines that have really huge towers, and they're huge corridors that you can see quite far down. And you can see these in the top two photos. And so the middle photo is actually a good example of what kind of grid or what kind of line the Wocawson Energy Project is connected to. So we work closely with New Brunswick Power to find the best connection, and then we sign an agreement with them to we sell the electricity we produce for 30 plus years. All right, I'm going to pass it off to Megan for a little bit here.
Thank you, Meg. Yeah, so a really important part of development is First Nations engagement. Evidently, we have partners with Tobique First Nation, but it's important to be in communication with all the nations that have used the lands historically. So the rest of the Wolastoqey Nation, as well as the Mi'kmaq who have used this land, and keeping them engaged from the real start of the project with all the data that we collect and our plans for the project, and learning from them as well. So two really important pieces of work that have come out of this, and Steve spoke really well to these as well in the previous presentation, are the Wolastoqey Land and Resource Use Study and the Mi'kmaq Indigenous Knowledge Study that were compiled for this project. And these are really large pieces of work that take a lot of time and effort to be compiled, that involve communicating with elders and land users to understand the historic use of this land into present. And as Steve spoke so well to this, and the difficulty and challenges in putting these reports together, and the large amount of trust that it takes to share this information with us as developers, and the importance of the recommendations that are provided through these reports to us, and to understanding our relationship and the relationship this project will have going forward as well, is very meaningful. Another great engagement piece that came out of this was cultural awareness training that was provided by members of Tobique First Nation to ourselves as members of the development team, but also to our construction and operations teams and the turbine manufacturers, so that we all understand the history of these lands and the people that have used them for generations and generations. Oh, next slide, please. So for public consultation, we use a variety of methods. We host usually 2 to 4 open houses throughout the development stage until the project is producing energy. So this involves having members of natural forces at stations where we're able to have one-on-one conversations with community members and stakeholders to really, be able to answer any questions that anyone may have and share information between each other that way. We keep our websites up to date so you can have a good idea of what's going on with the project, and we upload our studies and any frequently asked questions that people may have there. And then we share newsletters with nearby residences and businesses to keep them aware of project milestones and project activities. And we make ourselves available for one-on-one meetings or meetings with community groups and other stakeholders as well. So there's 2 main permits that we work through on this project. So a municipal development permit can really vary from municipality to municipality, but making sure that we're abiding with the bylaws and the rules that a municipality may have. And then the provincial environmental assessment takes a little while to put together. These studies are conducted over typically approximately 2 years, and then we'll go through rounds of comments with the regulators, which in this case are the provincial government of New Brunswick, and the Canadian Wildlife Services is typically involved in these conversations as well. So we work with consultants who conduct surveys to understand the uses of birds, bats, plants, vegetation, wildlife and habitat, the wetlands and watercourses on site, and to understand the archaeological context of the site. Then internally, we produce noise and shadow flicker studies. So this is to understand the level of noise that is emitted from the turbine and how that travels across the land, and if there is any shadow flicker produced. So shadow flicker is when the sun hits the turbine blade and it would have the potential to cast a shadow in a window. So by evaluating the potential impacts of that to nearby homes and businesses, and ensuring that we're siting our turbines far enough back that that's not an issue, and understanding any socioeconomic impacts that this project may have as well. Yeah, next slide. So it all kind of starts back in the site finding process that Meg went through. So we take data that's readily available through those sources that Meg mentioned to help the initial siting, but the project is really going to change a lot over time. So then after we do a review essentially at our desks of the environmental data that we're aware of, we head to site and get an idea of what's going on the ground. And then from there, our consultants join us and we develop study plans. So what will work well to study the birds and bats using the area and other wildlife, what seasons are appropriate to do different types of studies. And then we then share that with those that'll be reviewing the environmental assessment to make sure that these plans make the most sense. And we're often in discussions with stakeholders, rights holders, and land users to understand their understanding of the land, as they're the ones using it most frequently, and their input is so valuable. As you can imagine, with environmental studies, they stick to pretty rigorous timelines. So you have to be making sure that you're going out and collecting data at the right time of year. So I've got a couple of pictures up here. The first one on the left, where you can see kind of a post sticking up out of the ground, that's a bat monitor. So it is able to detect the frequencies that bats call at as they're traveling overhead at night. And so you have to make sure that you have a good open array of the sky to be able to capture that well. The next picture is a wetland that was delineated at Wocawson. And so you need to maybe making sure that you're going out and surveying at the right time of year, typically from about June 1st to September 30th, to make sure you're able to identify the vegetation and the water table well. And then the last picture on the right-hand side is pretty neat. We provide what are called photo montages. So it's a prediction of what the turbines will look like on site. So it takes into account the hills and the valleys and really the geography and topography of the land. And that predicts what the turbines might look like from a distance, so that the community members can be aware of, oh, this is what it looks like when I'm traveling by on the highway or from the road. Yeah, it's pretty neat. So something that's really important with environmental assessments is the melding of arts and science, really, and understanding how to best communicate the environmental data that we're gathering. So it might come in a kind of a complicated format, and then making sure that we're breaking down the information that we're receiving so that anybody that picks up the environmental impact assessment can understand what's happening. And so that's important not only in written format, but in the pictures and in the maps that we're sharing in these documents. So using shapes and colors and labels well to really send an important message. So this is one of several maps that we supply with the environmental assessment, but this ties into the photo montage that I showed in the previous slide. And the purple stars represent the locations that we generated photo montages for, and what the project would look like from that standpoint. Compared to the layout of the site. Yeah, so as all that data is collected and we learn more about the site and the different constraints that we have in developing, we then share all the information we've gathered with engineers, who then merge the science and the engineering together to create a project layout that is feasible and will work well for the wind regime, while being mindful of the land uses and the environmental context of the site. So from the previous slide to this slide, you can kind of see some of the iterations that we go through, and the initial sites that we identify in site finding will end up looking pretty different by the time we reach construction. But it's all an iterative process, and we're continuously learning and adapting to best suit the site. And so I'll just kind of wrap up here in my section by speaking to the turbine technology a little bit. It's pretty neat. You can always tell from the highway that you might be looking at some different turbines as you drive by projects. But wind turbine technology, we work really closely with our manufacturers to figure out what's the best turbine that we can put on a site. So it's dependent on a lot of factors: the project type, how many turbines that you have, and how close they might have to be together based on the available land area, the wind resource of the site, whether it's really consistent, or maybe it's more turbulent with higher wind speeds but different predictability, and of course the cost is going to play a role too. So all of these come together, and you match the best turbine model to the site that you're developing. And so kind of as a reference point, Meg kind of spoke to the size of the turbines earlier, but the hub height, so from ground to where the blades are going to attach to the nacelle at the top, is about 100 to 140 meters. And then combined with blades of 60 to 80 meters, you're getting a turbine height of approximately 160 to 220 meters tall. And as Meg mentioned, at Wocawson, the total height is about 200 meters, which is pretty impressive. And the turbines of this size can have a capacity of anywhere from 2.3 to 5 megawatts. At Wocawson, they're about 4 megawatts. So each turbine is providing enough energy for about 1,250 homes apiece, which is pretty neat. And what's been interesting over time is how initially turbine height and size was really increasing greatly as capacity was increasing, but now sizes are more standardized with varying capacity based on what your site is capable of. Which is pretty neat.
Yeah, and that's a really important point, because as we can, that allows us to be able to produce more electricity and impact the land a lot less. So we need fewer turbines to produce the same amount of electricity that we could in the past. So that's a huge development that has been great for the wind industry. So one more really cool thing we wanted to share about this project, the Wocawson Energy Project, was that we were able to really celebrate our partnership and highlight the community, sort of connect the community to the project, because the project is quite far away from the community, from the Tobique First Nation community. So, and when I say we, I really didn't have anything to do with it. It was all these artists. So there are two artists, Tara and John from Tobique First Nation, prepared and painted the art you can see here on 3 of the 5 turbines. And the symbology sort of brings, it brings in symbology that celebrates the community, both past and present, and their connection to the land. And it's something we're really excited about. It looks absolutely amazing on the turbines, as you can see in the bottom photo there. Otherwise, that would just sort of be a white surface. So I think it makes it look a lot nicer. And yeah, they did such a wonderful job. And then in addition to this, we're preparing a short film to celebrate their community and how much work they've put into this project, as well as our partnership, which will be on our website when it's done. Unfortunately, it's not quite polished up yet, but we were hoping to share it, but not today. And then finally, when the development team is done with our work, we pass it on to the construction team, and they sort of oversee all the construction activities. So the towers actually come in almost flat pieces and are assembled in sort of like small cylinders on site and then stacked. And so the stacking, so you can see that in this picture on the right, that they're putting it together. You can see the scale. These are people down here. Then the stacking of the towers and the installation of the blades and the nacelle takes a huge crane, which you can see in the middle photo. Really huge cranes on site, and yeah, and then we get to our final product. So yeah, and here's some pictures of the final product. This is what the project looks like. These were taken in the summer, fall, but we're hoping to get some more photos out when the weather gets nicer again and we're able to make it to site. So yeah, we'll leave it at that. Thank you everyone for your attention, and we're happy to answer any questions, or I don't know how we're doing for time, but we can also, if you have any other questions, Pam, you can share my information if you want as well. Oh, Pam, you're muted. Pam, you're muted there. We can't hear you. Sorry.
Thank you for telling me. We have a few minutes before our next presenters follow suit with some demystifying of wind power. If people would like to throw some questions up, I, for one, am so excited how you've married land use and Indigenous rights and partnershiping together, and wrapping it up with the artwork makes the wind project look even that much more unique, but especially timely as we look at, you know, wind energy in Texas right now and some of the issues they're facing because of unexpected climate. And I'm curious to learn more, but I know who and how to find you. If anyone would like to ask a question, I'll certainly leave the mic open and turn the recording off. And you have some chat, wonderful feedback in the chat. Are they working online now, is a question from Tobique.
Yeah, there are, the project is online now. It came online, I don't remember the actual date, but I believe it was in December. Is that right, Megan?
Yeah.
It's, I think two students assumed, as did I originally, that the project was in Tobique First Nation. I assumed that, and to find out that it was pretty much down the road from where I am was a shock. I didn't realize it.
Yeah.
Super presentation. What would be the range of projected revenue for this project? It's a question that just came in.
That's a great question. I actually don't have that information, but yeah, you can reach out to me and I might be able to find you something. But yeah, that's not really in my specific scope of work.
For those who are interested in learning more, I certainly have information, but Meg and Meg are rejoining us tomorrow in the second session. If you would like to come back or share with somebody who's missed it, tomorrow at 9:40, we'll see them again. It was fantastic.
Perfect. Thank you, Pam. Really appreciate it.
Thank you. And I will